Welcome back to another episode of Study Time on the Active Recall YouTube channel. In this video, we're just gonna hop into some basic IPv4 concepts in order for us to build our foundation of subnetting. We need these concepts molded into our brain in order for us to subnet efficiently and effectively, right? So let's just hop right into the content. IP addresses are 32 bits long, right? They contain 4 segments that are 8 bits each. There are 5 classes of IPv4 addresses, class A, B, C, D, and E. We're gonna be particularly concerned with class A, B, and C. These are the classes we're gonna use to network, subnet, etc., right? Class D is used for multicast groups. I think these are more so for like conference calls and groups of nodes interacting with one another, but just Google it. I'm not too sure what exactly we're using those for. And then we have class E, which is pretty much research and development, future use, and governmental use. So how do we identify each class of IP address, right? Say we have 172.16.0.1. How do we identify that as a class A, B, or C? Well, we just look at this first octet right here, and we see that it falls within this class range right here, right? Each class has a range that defines itself, right? So we have class A as 1 through 126. We got class B, that's 128 through 191. We got class C, that's 192 through 223. Class D, 224 through 239. And class E, that's 240 through 254. Now, as I mentioned before, we're not concerned with class D and E, at least not yet, right? Now, we also need to differentiate between public addresses and private addresses. So we reserved a private block for our internal networks, which are our home networks, our businesses. Wherever we have an internal network, we have a private block of addresses to use, right? These IPs are not routable. They're not unique, so we can't get onto the internet with them. Public addresses are required to get onto the internet, right? These are unique addresses and they have to be assigned to us by our ISP. We can get into the NAT, which is what I got right here, network address translation, in a later video. But when we have a public IP address, we can convert those IP addresses into private addresses using NAT. So that's just the basics of our public and private, right? We have class A, B, and C private IP addresses, right? And they're defined with these ranges. Class A is defined by 10.0.0.0 to 10.255.255.255. Class B, as we can see in our early example here, starts with 172.16.0.0 to 172.31.255.255. And our class C is defined by 192.168.0.0 to 192.168.255.255. Class C, we typically see that one when we're setting up our home network or what have you, and you're logging into a Netgear router or a Linksys router, whatever. You'll notice that the default IP address for your router or access point or whatever you're using is always going to be in class C. Now, you can jump in there and play around with that and change that. Some people like to change it to class A, some people like to change it to class B. That's their prerogative. You can use any one of these IP addresses when it comes to your internal network. Now, you cannot go outside of this realm here when we are in our internal network. That's a little review of public and private IP addresses, class A, B, and C. Public is an assigned address that you get that helps you get onto the internet, and private addresses are configured within your internal network. And we have this nice concept right here called NAT, N-A-T, Network Address Translation. We typically use our public IP addresses and we convert them into private IP addresses, and we're able to assign all of our nodes a private IP address. Now we have our subnet masks and we have our default masks, right? A subnet mask is used to divide an IP address into two parts, a network part and a host part. Subnet masks also correspond to a 32-bit long value. We can see here the default masks change depending on what class we're talking about. So if we're talking about a class A default masks, we have 255.0.0.0. What that tells us is that our network ID is right here. We're gonna get more into the whole network ID, host ID stuff when we get into subnetting. And in class B, we have 255.255.0.0. What that tells us is our network ID is right here. And class C, we have 255.255.255.0. That tells us our network ID is right here. On the flip side, that tells us that we have potential hosts right here, and right here, and right here, right? Our network ID values are locked. In our class A, we know that our network ID is always gonna be 8 bits, right? As we can see here, always gonna be 8 bits. Class B, we see that our network ID is always gonna be 16 bits. Class C, we see that our network ID is always gonna be 24 bits. This is helpful to know when we go into subnetting, because these are always going to stay the same while our host bits are going to fluctuate depending on how many subnet bits we borrow out of the host. What we have with an IP address is we have something that is, should I use binary? Because we can represent IP addresses in decimal and in binary, but I'll just use this whole 8 bits type of setup, right? So we have, let's say we have a class B address, right? It's typically gonna be something like this, right? We know N is equal to 16, and we know our hosts, this is bits, 16 bits and 16 bits, right? Now when we're subnetting, what's gonna happen is something like this, right? A company is gonna tell you that they have a certain amount of networks that they want, and they have a certain amount of hosts that they currently have. Depending on that information, you're going to modify this address so that you can give the company what they want as far as their networks and as far as their host. Remember, these stay locked, right? 8 bits network ID, 16 bits network ID, 24-bit network ID. Now say we have the class B, you have N is always gonna be 16. But now say you're subnetting for a company. What you're gonna do is, in order to start setting up these networks, you're going to start borrowing, some host bits, right? So say you borrow 3 host bits, right? You're gonna have 16 minus 3, which is going to be equal to 13. You're going to have 13 host bits here, and then you're going to have 3 subnet bits here, right? And that's going to give you the information that you need to start setting up your subnets. And I don't even want to go too deep into it because I already jumped ahead and I probably just confused everybody. But this is typically where we start to get into the juicy part of subnetting. So that's pretty much all I have to say for now. If you want to learn about just the basics of subnetting, I did a video before this one where you can just basically check out what subnetting is and why we subnet. That's all I have for now. So I'll talk to you guys next time.